Right, okay, so this video is about how to write redox equations. I'm going to show you through using examples about how to write redox equations. Okay, we're going to start off with a couple of more simple examples first. So let's take question 1. So construct the overall redox equation. Can you see that question 1, you have got two half equations, okay? They're called half equations. So you have got the iron 2 plus, and can you see that the electron has been lost? So that is the oxidation half equation. And can you see with the second equation with MnO2 that the electron has been gained, and that is the reduction half equation. Okay, now this question only has 1 mark because it's quite a straightforward question. You just have to add together the two half equations. Add them together and ensure that the electrons cancel out. So can you see that there's 1 electron in the top half equation and 2 electrons on the bottom equation? So we're going to times everything on the top by 2, like that, and then we're going to add together the two equations. So on the left hand side we've got 2Fe2 plus MnO2 plus 4H plus. That's everything on the left hand side of the equation, plus 2 electrons, and then everything on the right hand side of the equation, 2Fe3 plus plus Mn2 plus 2H2O plus 2 electrons, and then the electrons cancel out, and therefore you have got your redox equation, right? It's always a good idea, it's only 1 mark, I know, but it's always a good idea just to check it's balanced before you move on, like you do in maths when you're checking your answer in maths. So there are 2 irons on the left, there's 2 irons on the left, and there's 2 irons on the right, there is a 1 Mn, and you've got 1 Mn. You have got 4 H's, you've got 4 H's, and you've got 2 O's, you've got 2 O's. Just check the total charge as well. Total charge on the left is plus 8, and the total charge on the right is plus 6 plus 8 as well. Yeah. Okay, so that's a balanced equation, and that's only 1 mark. Now the second example has got 2 marks, and that's because it's more difficult. Okay, so again, you've got oxidation half equation, and you've got reduction half equation. There's a different number of electrons, so your first job is to make those electrons the same on each side, on the left hand side and on the right hand side. Some people think it's easier to think about this like equal signs, because if you think about it like equal signs, it reminds them of maths, So we're going to times everything on the top by 5. So 5 H2O2, 5 O2, 10 H plus, 10 electrons, and then times everything on the bottom by 2. So that'd be 2, that'd be 16 H plus, 10 electrons, 2 and 8, and then add them together, add the left together and add the right together. So I hope you're doing this at the same time. You're probably faster at it than I am. 5H2O2 on the left plus, now it's really easy to make a mistake, so just be careful, 2MnO4 minus plus 16H plus 10 electrons. That's everything on the left, and then everything on the right is 5O2 plus 10H plus 2Mn2 plus plus 8H2O. Haven't got enough room to write the electrons, plus 10 electrons, but we're going to cancel them out. We're going to cancel them out anyway, yeah? So I'm going to rub out the electrons. Okay, so now this question has got 2 marks, because if you left it like that, your answer like that, you would only get 1 mark, because you have to cancel out the H pluses. You've got 10 H pluses here, and you've got 16, so cancel that down to 6 H pluses, okay? And that's what you need to do to get the 2nd mark. Again, please just double check, is it balanced? Count up the hydrogens on the left. You've got 16 hydrogens on the left, you've got 16 on the right. You've got how many oxygens? You've got 10. You've got 18 oxygens on the left, and you've got 18 oxygens on the right. You've got 2 MNs, 2 MNs. Make sure your charge is balanced. The total charge on the left is +4, total charge on the right is +4. So you don't even have to look at a mark scheme. You know you've got the right answer because you've checked that it's balanced. Okay, so those would be seen as simpler questions. So I'm going to show you now some more difficult redox equation questions. For example, this question here. Using oxidation states, construct a redox equation. Okay, so we've got the dichromate. So I'm just going to change the pen color back to black. Okay, so we've got the dichromate ions. Okay, and it says the dichromate is reduced to Cr3+. Okay, so that means there's electrons on this side, yeah, because it's reduction. And it says use oxidation states. Okay, use oxidation states. So let's use oxidation states. Chromium is +3, okay, and chromium on the left. Now, if you're not sure how to work out oxidation states, you need to watch the video on how to work out oxidation states. So oxygen is -2, okay, and there's 7 of them, so that'll total -14. We need the whole ion to be -2, so that means chromium is +12. So each Cr must be +6. So the oxidation state of chromium on the left is +6. The oxidation state of chromium on the right is +3. But there are 2 chromiums, okay? So we're going to need to put a 2 there, yeah, a 2 there. So each chromium gains 3 electrons. So that means in total we need 6 electrons, okay? 6 electrons. Right, so we're not going to balance that anymore, okay? We're going to leave the half equation like that. And I know it's not balanced, but that is totally fine. We're going to leave it like that. It doesn't ask for a balanced half equation. It asks for a balanced redox equation. So Fe2+ is oxidized to Fe3+. That's a difference of 1 electron, where 1 electron has been lost. Okay, we need to make the electrons the same. So we're going to have to times everything here by 6. Okay, then we're going to add them up, just like we did previously. So the electrons are going to cancel out. Electrons are going to cancel out. So we've got the dichromate plus 6 Fe2+, everything on the left, and then everything on the right, 2 Cr3+, just went out of room there, 6 Fe3+, okay, and then we're going to now balance it. All right, so what is the total charge on the left? You've got 12 plus, yeah, and 2 minus, so that gives us a charge of +10. I'm just going to write it there so I don't forget. A charge of +10 on the left. On the right is a total charge of 6 times 3 is 18, plus 6 is 24. Yeah, so total charge of 24 on the right. We need to use the acid to help us. H plus to help us balance, okay? So plus 10 on the left, plus 24, that means we're going to need 14 H pluses. Yeah, 14 H pluses, and then we just need 7 waters because we've got 14 H's, and now your redox equation is balanced. Again, let's just double check to make sure we haven't made a silly mistake. We've got 2 chromiums, 2 chromiums, 2 chromiums, oxygens, we've got 7 oxygens, we've got 7 oxygens, 6 irons, 6 irons, 14 H's, 14 H's. Now, it's taking quite a while. This question would normally have 3 marks, yeah? And it's taking me a little while because I'm explaining it. But when you do it yourself, it is a lot quicker. Okay, let's try this question. Considering oxidation numbers, balance the equation. So let's start with copper. So copper is going to copper 2 plus. Okay, hopefully you can write that half equation. Can you see that it is oxidation that is taking place? Yeah. Then let's do the other one. So NO3 minus is going to NO. Okay. And the question says let's use oxidation numbers, considering oxidation numbers. Okay, so the oxidation number of N is plus 2 because oxygen is minus 2. Yeah, always minus 2, apart from the exception. Oxygen is minus 2. There are 3 of them, so that'll total minus 6. And therefore nitrogen will have to be plus 5. Okay, so nitrogen is plus 5. So we have got nitrogen. The oxidation state is being reduced from plus 5 to plus 2, a reduction in oxidation state, and that's 3, a change of 3 electrons. Okay, change of 3 electrons. Now we're not going to balance. We are not going to balance that half equation. We're going to leave it like that. We're going to balance the electrons. We're going to times everything by 3 in order to get 6 electrons. We're going to times everything here by 2 in order to get, times everything by 2 in order to get 6 electrons. Yeah, 6 electrons. Right, so everything on the left, we've got 3 Cu, and we've got 2 NO3 minus, and then everything on the right, 3 Cu2 plus and 2 NO. Don't forget that the electrons have cancelled out, so that's okay. Right, add up the total charge on the left is minus 2, the total charge on the right is plus 6. We need those 2 charges to be the same. We need to use the acid, so we're going to need 8 acid, and therefore we're going to need 4 waters in order to balance it on the other side. Yeah, 8H and 4 waters. Let's double check quickly. 3 Cu, 3 Cu, 8H, 8H, 2N, 2M, 6 oxygens, 6 oxygens. Total charge on the left is plus 6. Total charge on the right is also plus 6. And there you have your answer. Okay, here's another example. And 2 more examples. You're doing really well. Come on, let's see if you can beat me and do this quicker than what I can do it. The oxidation state of sulfur here, oxygen is minus 2, that's minus 8, so sulfur is going to be plus 6. Yeah, I is minus 1, is minus 1, iodine is 0 because it's an element, and sulfur here will be, hydrogen is plus 1, so sulfur will be minus 2. Yeah, let me just write that a bit more clearly. Okay, so those are the oxidation states. So sulfate is going to H2S. All right, so that is plus 6 to minus 2. Okay, so that is a reduction, and the difference is 8 electrons is the difference. Yeah. Okay, and we're not going to balance it any more than that. Then we're going to have a look at the other half equation. So that is iodide going to iodine. Now we do need to balance because we need to focus on the electrons and make sure we get the right number of electrons. So we do need to times that by 2 to make that bit balanced. The I needs to be balanced. Okay, can you see we're going to need to times this by 4. We're going to need to times it by 4. That's meant to be an 8. in order to get 8 electrons. Yeah. Then we're going to add them together. Add up the electrons are going to cancel out now. So we've got SO4 2 minus plus 8I minus goes to H2S plus 8I2. What's the total charge on the left? The total charge on the left is minus 10. Right, little message so don't forget. Total charge on the right is 0. They're not equal to each other. We've not used the H plus yet. Can you see we're going to need 10 H pluses? And don't forget, there's already 2 hydrogens there. So we're only going to need 4 waters. Okay, we're only going to need 4 waters. And then just check it's balanced, not made a silly mistake. 1 sulfur on the left, 1 on the right. 4 oxygens, 8I. Oh, there you go. I have made a mistake. 3 times everything by 4. Did you spot my mistake? Oops. Times everything by 4. Why did I write a number 8 there when we were timesing everything by 4? And there you go. That's an example of why it's really important to check your answer. So let's just check one more time. So because here what we did was here we times everything by 4, not by 8. So we've got SO4 2 minus, we've got 1s, 4 oxygens, 8 I's, 10 H's, 10 H's. Okay, so that's why it's important to double check. Let's try one more example. So write an equation for the oxidation of aqueous iodide ions. So we've got iodide ions going to iodine and its oxidation. So we need 2 electrons like that. Okay. Nitrate 3 ions. What's the formula of nitrate 3? Well, the 3 in Roman numerals is the oxidation state of nitrogen. So that's going to be plus 3. Oxygen is minus 2. Should have told you there it's a 1 minus charge overall. I should have told you that. So therefore we're going to need 2 oxygens. So therefore the formula is going to be NO2 minus. Okay, and that is going to be reduced to NO. So that's plus 3 nitrogen. That's plus 2 nitrogen there. So that is a difference of 1 electron. So I'm kind of trying to go really quickly, because I know you don't want a video that is too long. So I'm trying to go really quickly. Okay, so you're going to add them up. First we need to cancel out the electrons times everything by 2. So we've got 2I minus on the left and 2 NO2 minus on the left. And that goes to I2 plus 2 NO. Total charge on the left is minus 4. There isn't any charge on the right. We need to use hydroxide ions. So we're going to need 4 hydroxide ions in order to make the total charge the same. We're going to need some water, aren't we, for the hydrogen. We're going to need 2 waters, and make sure, let's just double check it's balanced. So there's 2I, 2N, 2N. 4 H's, and 6 oxygens. Okay, so therefore in summary what we need to do is, when you're doing these redox equations, okay, so the first thing to do is to write 2 half equations first. Yeah, so write 2 half equations, and they don't need to be balanced. Yeah, just ensure that the electrons are balanced. Okay. Ensure that the items that are oxidized and reduced are balanced. Ensure that the items that are oxidized or reduced are balanced. Okay, that's all you need to do. The items are oxidized or reduced. Okay, then you need to ensure that the number of electrons is the same on each half equation. Ensure the number of electrons is the same. is the same on in each equation. Okay, then you need to add up half equations and cancel out electrons, and cancel electrons, and cancel electrons. So you need to add up half equation, cancel electrons, and then number 4, you need to balance the charge using either, and the question will tell you, using either H plus or hydroxide. Then you add water to balance, and then do not forget is to check your answer so you don't make a silly mistake. Okay, check your answer at the end. Okay, thank you.